Hi, boys and girls. This is your practice test. The first thing I want you to do when you're looking at your practice test is put your first and your last name. My first name is Mrs. Eschrick. You notice how I put my last name on it? Okay, not just your first name, your last name, and your hour. Okay, let's look at question number 12. I'm sorry, for target number 12. 40 students, do you see 40 students? Pick a card out of a pile and put it back. Students get a prize if they pull out a jack. Here are the results. King, they pulled out 7 out of 40. Queen, 9 out of 40. Jack, 5 out of 40. Ace, 8 out of 40. And Joker, 11 out of 40. Okay, what is the experimental, let's underline experimental, probability of winning a prize getting a jack? Okay, well, how many jacks are there? 5. How many, I'm sorry, they hold a jack 5 out of 40 times out of 40. Now, that is a fraction, it's a probability, but it's not simplified. We can take 5 into both 40 and 5 and have it be 1. 40 divided by 5 is what? 8. So he has 1 out of 8 chances of pulling a jack and winning. Okay, how do we get this denominator? Okay, right up here it says 40 students pick a card. Okay, now remember when we said it's or and? This should be and. That we add them. So what is the experimental probability of picking a king or an ace? Well, let's look at king. Here's king, 7. Here's ace, 8. We're going to add those up. 7 plus 8 is 15, correct? So then it's going to be 15 out of 40. Okay, once again, that is not in its simplest form. What number goes into 15 and 40 evenly? Well, I see that this both ends in 5 and 0, so we know 5 does. And we're dividing it by 5 over 5, so that is 3. Once again, 8. And that's our answer. Let's look at target number 13. There are 15 cards. I like to underline the important words in a story problem. In a pile, and 4 of them are jacks. Jacks get the prize. What is the theoretical probability of not winning a prize? Do you see how it says not in bold? Okay. Now, we don't know how many times they pulled it. This is just what happens in theory. So we know 15 is going to be our denominator, right? Because there's 15 cards in all. 4 of them are jacks. How many are not jacks then? We go 15 cards in all, minus the 4 jacks, and we'd get 11 cards are not jacks. So our probability of not winning the prize is 11 out of 15. For number 4, it says use the spinner below to answer the following. A, what is the theoretical probability of the spinner landing on red? Well, there's 1 red, right? And how many in all? 1, 2, 3, 4, 5. Oh, I'm sorry, there are 2 reds. Oops, missed that. 2 reds. 1, 2. Out of 6 in all. So we have 2 out of 6. Right? So are we done with that? They're both even, so we can make that 1 over 3. Give an example of a certain event when spinning the spinner. Well, let's look at that. A certain event, could we get yellow, green, red, blue, red? Okay, a certain event when spinning the spinner is we're going to get a color, right, of red. Let's say red or blue or yellow. And you can pick which one you want, right? List the sample space. The sample space is just the outcomes. Well, what are the outcomes here? Kind of similar to the question before. Yellow, green, blue, red. Did I miss any? Hope not. Okay. Target 14. Is it possible to construct a triangle-shaped game board with the side lengths of 11, 16, and 5? Remember how we did this? We pick our two smallest numbers, 5 plus 11, and that gets 16. And that has to be greater than the largest number. Is 16 greater than 16? No, it is not. So you can't make a circle. I mean, I'm sorry, you can't make a triangle. Remember, to make a triangle, the two smaller ones have to be greater than the larger one. Which combinations of these lengths can form a triangle? There may be more than one. Well, all we do is for this is we add our smaller ones. 10 plus 12 is 22. And since 22 is greater than 18, 1 can. Okay, for here it's 17 plus 5 is 22. Since 22 is the same as 22, it is not. 4 plus 4 is 8, and 8 is smaller than 9, so that doesn't work. So which one is the correct answer? B only. Classify the triangle by the lengths of its sides and the measure of its angles. Well, it says right here that this is 128 degrees. All three sides are different, so it's going to be scalene, because they're all different, and obtuse, because it's larger than 90 degrees. Find the missing angle. You got this. We're going to go 128 plus 36 equals 164. Okay, then we take 180 minus 164. You get 16 degrees. Okay, find the perimeter of the shape below. Super easy. That'd be 16 plus 11 plus 12.5 plus 21. Those up, it is 60.5. Just said perimeter, didn't say area. Find the missing measurement for a trapezoid whose perimeter is 105. Okay, so if this plus this plus this plus this is 105, we'll need to add these up. 33 plus 20 is 53. I can do that in my head. 33 plus 20. Add 9 is 62. Then we're going to have to, it's 105 in all, so it's 105 minus 62, 3, 4. 43 inches. Find the area of the trapezoid. We talked about this. We're going to add 12 plus 7. We're going to take the average of this and this. 12 plus 7, you get 19. 19 divided by 2 is 9.5. And then we're going to times that by our height. Remember, our height is perpendicular to our base. Okay, I'm just going to take my calculator. Oopsie, I'm not showing this, am I? Oopsie. I'm going to take my calculator and go 9.5 times 5 and get 47.5 centimeters squared. Don't forget to squarea the area. Last page. It's kind of hard to see. Find the area of the triangle. 20 times 4 is 80. Divided by 2 is 40 inches. Find the missing angle. 4 angles have to add up to 360. 112 and 112 is 224. I just did that mentally in my head. Okay, that adds 68 here. So we have 360 degrees in all, every four-sided. We subtract that. 92, that's 8. That's 15, that's 68. Did I do that right? 10, carry the 1, 6, yep, 68 degrees. What are the sum of the angles in an octagon? Remember how we make this into triangles? Okay, so we go 1 triangle there, 2, 1, 2, 3, 4, 5, 6, 180 times 6, 48, carry the 4, sorry, 0, 48, carry the 4, 1080. And you can use your calculator so you don't make a mistake. Reviews. What is the greatest common factor and least common multiple of 15 and 18? Okay. Multiples are multiplying. Factors are math facts. Okay. So let's do GCF first. Factors of 15 are 1 and 15, 3 and 5. Factors of 18 are 1 and 18, 2 and 9, 3 and 6. So the greatest common would be 3. Okay. Multiples, we get a fresh, I'm going to just do it down here. We're going to go 15, 30, 45, and stop like I tell you to, 18, 36, add another 18. 18 times 3 equals 54. 18 times 4 equals, oopsie, 18 times 4 equals